Okay, thank you for communicating in your thoughts on that, by the way. Now, let's get a bit technical now. There are multiple layers of clustering in a RAC environment. There are multiple layers of clustering. I'm just going to put the layers up in a notepad here. We have the hardware cluster. On top of the hardware cluster, we need to build an operating system cluster. So we have the hardware cluster. Then we have the operating system cluster. Then we have the storage cluster. And finally, we can have the database cluster, which is the RAC. And each layer of clustering is totally dependent on the layer preceding it. So remember that, you've got 4 layers of clustering. That's the way I think of it, anyway. And you have to go through them layer by layer, starting from the first one, ending up at the last. Now, beginning with the hardware cluster. So what can we do with the hardware cluster? Well, I'm going to begin by attempting to sketch a diagram. I have a very nice drawing tool that Dave bought me the other day, but I'm still to a certain extent learning how to use it. But I'll do my best with my drawing tool. Now, let's wait till it starts up. There we go. So the hardware cluster consists of nodes connected in 3 ways. Nodes connected in 3 ways. Now, so what I'm going to do here, I'm going to sketch out a simple 2-node cluster. So I'll have one node here, which I'll just draw as a box, and another node here. So I've got 2 nodes. And each node has its CPU, probably several of them. It's got its RAM, and it will have some sort of local disks. So each node, CPU, RAM, local disk. The nodes are connected in 3 ways. You see here, we have, I'll come to the topologies by the way in the next step, just doing the slides in the other order. They are connected with the interconnect, the public network, and a shared path to disk. So, beginning with the private network, there's a private network between the nodes, known as the cluster interconnect, private network. The private network, in theory, could just be a pair of Ethernet cards and a crossover cable, but that will be totally unsupported. Then the nodes are connected to the public network. The public network is probably your Ethernet up here. So we have a network interface card onto the public network. Now the public network, that's where your end users are. That's where, for example, your application servers sit. They're on the public network. Then the third connection between the nodes is a shared path to disk. We have a shared disk system. There are any number of technologies for the shared disk system, but one way or another, both nodes are connected physically to the shared disks. That's your hardware cluster. 2 nodes with their independent resources connected in 3 ways. What I just sketched out there is the shared disk cluster. The shared disk cluster is used in, I don't know what the percentage is. I shall say the vast majority of Oracle cluster databases in the 21st century are shared disk clusters. Purely for academic interest, because of that, the other topology is a shared all cluster. A shared all cluster means that the CPUs on each node have access to shared memory as well as shared disk. Shared memory as well as shared disks. So all the CPUs can see all the RAM, all the CPUs can see all the disks. Whereas in this environment, of course, the CPUs can see shared disks, but they have private memory. The memory is private to each machine. So the shared all cluster, Oracle doesn't acknowledge as being a cluster at all. Basically, it's like an SMP machine. You can't run a RAC on an SMP machine. Oracle does not run on shared all clusters. The bottom is the shared nothing cluster. I used to use that quite a lot in the old days when I was working with IBM a lot. With the shared nothing cluster, not only is memory private to each node, the disks are also private to each node. So you don't have true shared disks in a shared nothing cluster. And it worked brilliantly in IBM in the old days because IBM has, this was HACMP, IBM's clustering software, and they have what they call the virtual shared disk structure, which increased scalability incredibly, but I haven't seen that used in many years. So you're probably using a shared disk cluster, 2 or more nodes connected in 3 ways: public network, private network, shared path to disk. And that, on our course, is what we deliver to you when you first join the course. You have your own cluster with the hardware in effect configured already.
Pardon me, John. A question about ODA.
Yeah.
Oracle database. Oracle database appliance. So, question came in the queue. Each ODA node has 4 10-gig Ethernet network interface cards, plus 2 InfiniBand NICs. How are they used?
Okay, with ODA, the standard environment is you've got the InfiniBand is used for the private network, and each of your 2 ODA nodes has 2 InfiniBand interfaces. You've got 2 InfiniBand interfaces on your private network. I've just drawn 1 there for 2 reasons: fault tolerance and, guess what, scalability. The private network is a single point of failure. Hence, it's a good idea to have at least 2 physical routes for the private network. And that's why with ODA, you've got 2 InfiniBands for it. It also gives you scalability, because the scalability comes in if 2 InfiniBand connections won't give you double the performance, mark you, because the clock speed, the transmission speed of the InfiniBand is the same. But having 2 does potentially give you double the bandwidth. And that interconnect can be a problem if it gets flooded. Then you've got, in ODA, you've got your 4 10 gigahertz copper network cards, and they're used for communications to the public network. So basically, ODA, you've got 2 times InfiniBand fiber there, and then you've got potentially 4 times 10 gigahertz Ethernet to the public network. Now, there's a subtle change there, and you can see the way I've sketched it here with just one, basically just 1 network card there. You can see that that now becomes a single point of failure. That network card fails, and in effect, you've lost the node. Whereas if you have 2, again, you've got some fault tolerance. But there's a big difference in the way Oracle will use multiple private network interface cards and multiple public network interface cards. And that's to do with what we call network interface card bonding, the bonding. And I'll demonstrate bonding later on, how to configure it. ODA configures it for you. Okay, thank you for that question, by the way.
There's a follow-up question from Paul in the queue, the online queue, in the meeting. What do they share? Just CPU?
Oh, in the shared nothing. All right. Yes. In the shared nothing cluster, what that means is basically nothing is shared at all. The way the CPU works, with a shared nothing cluster, each node, let me draw my diagram back here, each node has only its private disks in a shared nothing cluster. Each node has only its private disks, no shared disks. And you rely on an extra layer of software to make the local disks on each machine visible to the CPUs on all machines. So there is nothing shared at all. But you have clever operating system software that makes it look as though the disks are shared. We're not talking something as simple as NFS. With IBM, virtual shared disk was a much more sophisticated system than that. But in principle, nothing was shared at all in that environment. It was just IBM software, AIX, fooling Oracle into thinking it was shared. It sounds very inefficient, but in fact it scales limitlessly because you've got that extra layer of intelligence. If you're using shared disk, as virtually everybody does, there are strict limitations on how big the cluster can be. And when I say strict, yeah, those limitations are now pretty astronomically big. But for example, not so long ago, a Linux cluster could have only 16 nodes because of limitations of shared disk, whereas the shared nothing scaled limitlessly. Well, thank you for questions. Always good to get interaction like that. And if my answers don't make sense to you, don't hesitate to challenge me on them. Having built our hardware cluster, we then need to build the operating system cluster. And that is grid infrastructure itself. The purpose of your clusterware is to monitor and control the resources. And what are the resources? Databases, virtual IP addresses, listeners, application servers. Those are the resources we're going to manage. We have to share access or mediate access to the shared resources. The most important shared resource is the disk, the shared disk. We need the capability to have what they call a heartbeat. The operating systems on each node have to become aware of the operating systems on the other node. So let's see what would happen here if we had a problem. Now, I'm going to draw my operating system cluster, and I'll draw it in blue. So the operating system cluster is operating system modules, kernel modules. So on this node on the left, we start the clusterware daemons. And on this node on the right, we start the clusterware daemons. The clusterware daemons talk to each other across the interconnect. The heartbeats. In effect, the clusterware on each side pings the clusterware on the other side. It broadcasts, or multicasts to be precise. You multicast messages on the private network. And each clusterware daemon multicasts messages saying, hello, here I am node 1. And this clusterware here on the right says, hello, I'm node N2. The clusterware daemons monitor the interconnect to receive the messages from the other nodes. And that allows the clusterware daemons to build up the topology of the cluster. So node 1 detects node 2 detects node 1. So they think to themselves, ooh, we're a 2-node cluster. Great. Now, that's necessary because of the shared resources. The most obvious resource being this disk here. Imagine the situation where something goes horribly wrong and maybe you lose a node. So, no, before we do that, cooperation. This is directly attached storage. If node N1 writes to the file system at the same time as node N2 writes to the file system, you'll destroy the file system. They'll total, the inode table will be destroyed because there's no intelligence there. This isn't a file server, it's just disks. So you have to coordinate writes. Otherwise, the writes will collide, you'll destroy the file system structures. That's straightforward. There's no brains down here, it's just a disk. But they talk to each other, they communicate, and they cooperate. So that's all very well. And then if one of the nodes fails, say node 2 on the right, boof, node 2 fails. Kernel panic, operating system crash, network drops out, you lose the node. Node 1 will realize that node 2 is gone. So it will reconfigure the cluster topology and take control of the disk itself. No problem. Then node 2 reboots, Unix starts, clusterware daemons start, it rejoins the cluster. And node 1 says, oh, hello, you're back. And they start cooperating again. Easy, isn't it? But think of a problem that's a bit different. Maybe node 2 didn't reboot. Maybe it was a network problem on the interconnects. Poof. Well, node 1 has lost contact with node 2. So it's going to think, hey, the disks are all mine. Chat in. What do you think node 2 is going to do? Node 1 has lost contact with node 2. What's happening at the node 2 side? Spot on, Philip. Spot on. This is what you call a split brain. The split brain. I love that metaphor, split brains, like we're chopping through the two lobes of the brain. That's exactly it. Good. We're all getting there. Perfect. Thank you for the feedbacks. So, The split brain is a problem that all clusterware publishers have to deal with because the results are disastrous. It would mean uncoordinated disk writes, which would destroy the disk system. To get around that, Oracle uses what they call the Quorum Disk, or the voting file. It's a disk-based structure. Oracle calls it the vote disk. The vote disk. Some other technologies call it the Quorum Disk. It's a disk-based structure that the clusterware daemons talk to. So the clusterware daemons not only ping each other across the interconnect, they also write to the vote disk their impression of the cluster. So node 1 writes to the vote disk, I'm node 1, I can see node 2. Node 2 writes to the vote disk, I'm node 2, I can see node 1. And that's pretty cool, because now, if you lose that, node 1 writes to the vote disk, node 2's disappeared. Node 2 writes to the vote disk, node 1 has disappeared. Oh dear. And by that means they can realize that they're both still alive and the problem is up here. And at that point, one of the nodes will then leave the cluster voluntarily. That's what we call a node eviction. In earlier releases, the node would reboot, which is a bit drastic, but it works. In later releases, it's a more elegant failure. So that's the operating system cluster. It allows the operating systems in each node to become aware of each other and build up the topology and handle split brain and what is called I/O fencing. And there's a bunch of daemons that handle it. Having done that, we can build the storage cluster. Right, the storage cluster. This is where there are all sorts of options, and we have whole chapters on this in our course. We have at least a whole day on ASM, for instance. But basically, you've got to choose your storage. Raw devices are history. They're no longer supported. If you have any databases using raw devices, heaven help you, and get rid of them immediately. Not the databases, the raw devices. Third-party clustered file systems are fully supported. If you've bought IBM's GFS, great, use it. If you've bought Red Hat's GPFS, sure, use it. You'll be paying, of course, if you've bought Veritas Clustered File System, or Semantic nowadays, isn't it? Sure, use it. Fully supported, but of course you pay. Oracle will let you use OCFS2, but I see that as being a technical backwater. It's still fully supported. I can see no justification for using it because there's better technology now. NFS is fully supported, and NFS, I must say, I love working with NFS for RAC. It's incredibly easy and I understand it. And my background was in system administration before I sort of wandered over and became a database administrator. So NFS is like second nature to me. It's really easy to work with, fully supported for RAC. ASM is the big one though. Most sites in the 21st century use ASM for their shared storage. But if you already have a third-party clustered file system, sure, use it. OCFS I would try to get off. NFS, perfectly acceptable. If you've got a NetApp filer, sure, use it. But ASM is the big one. Now, built on top of ASM, you can use the ASM clustered file system. Very good technology. And I should mention, by the way, in ODA, we had a question about ODA earlier, didn't we? With the ODA for the last couple of releases, ACFS built on ASM has in fact been the default storage on an ODA cluster. But the underlying technology for ACFS is ASM. Whatever you're doing to these shared devices, you've got to have multipathing. I've sketched out only one route to those devices. If that route fails, you're in big trouble. So if you're using NFS, have 2 network cards on a dedicated storage network to get to the NFS server. So you've got multipath to it. If you're using LUNs, fiber-attached LUNs, don't just have one host bus adapter getting you to the SAN. Have 2. You always want to make sure you've got some fault tolerance getting to the shared disk.